Previously, I had introduced the idea of circuits and the idea of electricity using this analogy with a bucket brigade. And with that, I just introduced the basic fundamentals of a circuit: charge, resistance, voltage, the charge is moving, current, all that type of stuff, just in a very simple format of a very fundamental circuit. What I'd kind of like to look at today is, as the saying goes, take a look at the rest of the story. And the rest of the story are the types of circuits that we can have. So this was the picture that I ended up drawing with the introductory circuit, with the fire brigade pulling water from a pond or some type of water source and dumping it on a house that was on fire. I want to take that idea one or two steps further. So let's say we have the situation where, unfortunately, we don't have one house on fire, we have two houses on fire, and these two houses are essentially right beside each other. So there's our two houses on fire. Maybe they're right beside each other, they're neighbors, whatever, it doesn't really matter. And over here we have our pond water source. And the bucket brigade's faced with the dilemma of putting out both houses, and they decided that they're going to try to attack both at one time. And so our fire brigade assembles. So if you give me a second to draw those in. Not only does the fire brigade go to the first house, it goes to the second house. So our fire brigade stretches completely from the water source to the first house. And of course we have our first guy in the brigade that gets our bucket full of water. There's our water in the bucket, and this bucket gets passed on from person to person. And so what they decide is that when they get to this house, they're going to throw some water on the fire. Maybe just a little bit of water. So I'm just going to write some water. They then think, okay, we're going to continue passing the bucket down. We're going to throw the rest of the water onto this fire. And so this is the rest of the water. The bucket gets sent back, refilled, the process repeats, and once again we hope that we have a lot more than one bucket where this is a continuous process. Pass in water, dumping a little bit on house number one, throwing the rest of the water on house number two, until hopefully both are put out safely. I previously made the analogy that the bucket is the same thing as the charge. In an electrical circuit, the charge moves, the bucket moves. The people represent the electrons. In an electrical circuit, electrons don't actually move, it's just the charge. The electrons pass the charge on from one electron to the next, like the people pass the bucket. I previously made the analogy that the water represents energy. The bucket carries water, the charge carries energy from the water source, from our energy source, sometimes called a battery, our power supply. The charge carries energy from our power supply to where it's needed. And where it's needed are called the loads, or the resistors. So let me just call this resistor 1. And I'm going to call this resistor 2. That's basically what's happening. That's my parallel to the bucket brigade and to this electrical circuit. At house number 1, or resistor number 1, since we're putting some water on this fire, what that means is we're putting some energy into this resistor, and we're putting the rest of the energy into this one. So we're using, the charge leaves with a certain amount of energy, it's going to use it all. And so whatever's not used on house number 1, it's going to be used on house number 2. The rest of that energy is going to be used on house number 2. Since the water level in the bucket changes, when we throw some of the water on house number 1, we're going to experience a change in water level. So let me put change in water in the bucket. This change, as I kind of talked about before, is my voltage. Volts is, in a sense, how much the energy level of the charge changes. So we're going to put so much voltage into house number 1. The rest of the voltage, the rest of the water, is going to go into house number 2. So I'll put V1 for house number 1, V2 for house number 2. It makes sense that if we start out with a total amount of water, with a total amount of voltage from our power supply, a full bucket of water, if we put part of it in house 1, the rest of it in house 2, then my total amount of water is equal to these two voltages added up. And that's how it works with this type of a circuit. This is a series circuit. One resistor right after another. So if you hadn't picked up on it, this is a series circuit. With a series circuit, we're going to lose a little bit of voltage at resistor number 1. We lose the rest at resistor number 2. The total amount of voltage at both resistors in this case is going to equal what I began with. So that if I began with 1 gallon of water at the pond, it's going to be split among these two houses. And that's the way it's going to work. The other thing to keep in mind is that in order to make this fire brigade as effective as possible, the fire brigade has to move at the same speed. They don't want to move too fast in one spot, too slow in another. You're going to get a log jam. You get a big space. You need to have a continuous flow of water, that continuous flow of that bucket down the line to be as efficient as possible. And so what that comes down to is we need a constant or steady bucket movement. That's the best way. That's our ideal situation. No holdups, no gaps. We're fighting this fire. Now, what this means, and what I talked about before, was how fast the bucket is moving. We have a constant current. How fast the bucket moves is the current involved in the circuit. And so in this situation, with a series circuit, we will have a constant current everywhere throughout the circuit, through resistor 1, through resistor 2. The voltages add up. The amount of energy used through resistor 1 is equal to the amount of, plus the amount of energy used through resistor 2, adds up to the total amount of voltage from our power supply. These are some of the characteristics of a series circuit. Now, so let's do this real quick. Now, I've got this expression that my total voltage is equal to volt 1 plus volt 2. Let's go ahead and apply, in this case, now we're going to start applying Ohm's law. V equals IR. And so where I have total voltage, I'm going to plug in IR. And if I'm talking about total voltage, I'm talking about total current times my overall resistance. My total resistance is equal to current through resistor 1 times resistor 1 plus current through resistor 2 times resistor 2. I said we have a constant current, which means the current throughout the entire circuit is the same, which means my total current is equal to my current through resistor 1, which is equal to my current through resistor 2. That's one of the characteristics of a series circuit. So all these values for my current are the same. So I'm going to simply rewrite this as current times total voltage is equal to current times R1 plus current times R2. And what we see is that we can simplify that expression by dividing through by current, and what I'm left is an expression that says my total resistance is R1 plus R2. In a series circuit, or when resistors are in series, we just add up the resistances to get the total resistance of that entire of that circuit. These are some of the characteristics. These are some of the characteristics of a series circuit.